Episode 20. Was the Scientific Revolution revolutionary? An AP European History podcast by Hammer History Productions. Over the past few episodes, we've been talking about the scientific revolution, new discoveries about the universe, new ways of thinking about nature, and major figures like Copernicus and Galileo. But today, we're stepping back to ask a bigger question. Was this actually a revolution, or is that label misleading? Dr. Morgan, can we start there? What do historians even mean when they call something a revolution?
That's a good place to begin, Miles. When historians use the word revolution, they're usually talking about a major turning point, something that represents a significant break from the past. But that definition can be tricky because most historical change is gradual. So the question becomes, how much change is enough to count as a revolution?
And that's where historians start to disagree. Because calling something a revolution isn't just describing the past, it's interpreting it. It's a judgment about what matters and how change happens over time.
So this isn't just about science, it's about how historians think about history itself.
Exactly. This debate really comes down to a classic historical question. Was the scientific revolution a sharp break from the medieval past, or was it more of a continuation of earlier ideas and developments?
Okay, so let's get into the two sides. Dr. Morgan, what does the first historian argue?
The first argument comes from Edward Grant, and he says, yes, there was a scientific revolution, and it was a major turning point in history. He points to what he calls momentous changes in fields like astronomy, physics, and cosmology during the 16th and 17th centuries. Think of figures like Nicholas Copernicus proposing heliocentrism, Galileo Galilei using telescopic observation to challenge traditional models, and Isaac Newton developing laws of motion and gravity.
So for Grant, this really is a big shift.
Yes, but with an important nuance. Grant doesn't argue that these changes came out of nowhere. In fact, a major part of his argument is that the scientific revolution was built on earlier developments in medieval Europe.
Which is interesting because it means he's not saying the past was irrelevant. He's saying the opposite, that the Middle Ages actually made the scientific revolution possible.
That feels a little counterintuitive. I thought the scientific revolution was about breaking away from medieval thinking.
That's the traditional story, but Grant complicates it. He argues that several key developments between about 1175 and 1500 created the conditions that allowed modern science to emerge. In other words, if you removed those medieval developments, the scientific revolution either wouldn't have happened when it did, or might not have happened at all.
So what kind of developments are we talking about?
The first major one is the translation movement. During the Middle Ages, European scholars translated a large body of Greek and Arabic scientific works into Latin, works by Aristotle, Ptolemy, and later Islamic scholars like Ibn Sina and Ibn al-Haytham. This brought advanced knowledge, especially in mathematics, astronomy, and medicine, into Western Europe.
So Europeans weren't starting from scratch.
Not at all. And Grant is very clear about this. He argues that without these translations, Western Europe would have been intellectually behind for much longer. The scientific knowledge that early modern thinkers built on was already being preserved, studied, and debated centuries earlier.
And that highlights something important about intellectual history. Knowledge builds over time. The people of the 17th century were working with ideas that had been circulating and developing for hundreds of years, even if they didn't always realize it.
Okay, so translation is one piece. What else?
The second major factor is the rise of universities in medieval Europe. Institutions like Paris, Oxford, and Bologna, founded around the 12th and 13th centuries, created a structured environment where science, what they called natural philosophy, could be studied, taught, and debated over long periods of time.
So this is where science becomes more organized?
Exactly. Universities didn't just preserve knowledge, they standardized it. They created shared curricula, trained scholars across generations, and spread similar ideas across Europe. That kind of institutional support is critical if you want sustained intellectual change.
And it also shaped how people thought about knowledge itself. In universities, scholars were trained to use logic, argument, and systematic reasoning. That mindset, questioning, debating, refining ideas, becomes a foundation for later scientific work.
So we've got translations in universities. What's the third factor?
Grant points to the emergence of what he calls theologian natural philosophers. These were scholars who combined religious study with the investigation of nature.
Wait, so religion actually supported scientific development?
In many cases, yes. Medieval scholars didn't necessarily see science and religion as opposites. Instead, they often believed that studying nature was a way to better understand God's creation. That made scientific inquiry not just acceptable, but meaningful.
And that matters politically and culturally. If scientific thinking is seen as legitimate within a society, especially one dominated by religious institutions, it has a much better chance of developing and spreading.
So for Grant, all of this creates the foundation for the scientific revolution.
Exactly. And here's his key point. The scientific revolution was revolutionary, but it didn't come out of nowhere. It was the result of a long process that reached a turning point in the 17th century. He even argues that many of the questions early modern scientists asked were inherited from medieval thinkers. What changed were the answers, and increasingly, the use of experimentation to test those answers, something we can see clearly in figures like Galileo conducting motion experiments and Robert Boyle working with air pumps and early chemistry.
So it's both continuity and change.
Right. Grant even points out that many of the questions scientists were asking in the 17th century were the same questions medieval scholars had been asking. What changed were the answers, and increasingly the methods used to find them, like experimentation.
That makes sense. Okay, so that's the yes argument. Professor Theo, what about the other side?
The opposing argument comes from Stephen Shapin, and he takes a much more skeptical view. He actually begins with a pretty bold statement. There was no such thing as the scientific revolution.
That's a strong claim.
It is. And what he means is that the idea of a single, unified scientific revolution is misleading. He argues that this label was created much later by historians, not by the people who lived through the 17th century.
So people at the time didn't think they were part of a revolution?
Not in the way we think about it now. The term itself wasn't even widely used until the 20th century. So Shapin is questioning whether we're imposing a modern interpretation onto the past.
That sounds like presentism, judging the past based on modern ideas.
Exactly, and that's one of his main concerns. He argues that when we label this period a revolution, we risk oversimplifying what was actually a very complex and uneven process.
What does he mean by that?
He points out that there wasn't just one kind of science happening in the 17th century. There were many different approaches. Some focused on mathematics, like Newton's physics, others on observation, like Tycho Brahe's detailed astronomical records, and others on experimentation, like Boyle's laboratory work. And they didn't always agree with each other.
And that's important because it challenges the idea that there was a single, unified scientific method emerging at this time.
So instead of one revolution, it's more like a bunch of different changes happening at once?
Exactly. And Shapin pushes this even further. He argues that what we call science in the 17th century wasn't even a single, clearly defined activity. Different people were trying to understand nature in very different ways, using different tools and methods, and often disagreeing about what counted as valid knowledge.
So even the definition of science wasn't settled yet.
Right. And that makes it hard to talk about a single revolution, because there isn't one unified thing that's being transformed. Instead, you have multiple traditions evolving at different speeds.
He also emphasizes that these changes didn't affect everyone equally. In fact, most people in 17th century Europe weren't involved in these developments at all. Most were farmers or laborers who would have had little exposure to figures like Galileo or Newton or the ideas they were developing.
So, for most people, life didn't suddenly change because of science.
Exactly. The idea that the scientific revolution transformed how everyone saw the world is misleading. These new ideas were limited to relatively small groups of educated individuals, and even within those groups, there was disagreement.
Some thinkers supported new approaches, others resisted them, and many tried to combine older ideas with newer ones. So instead of a clean break, what you see is a lot of overlap and debate.
So change was messy, not clean.
Exactly. And that's why Shapin prefers to think in terms of continuity rather than revolution. He argues that many so-called new ideas actually developed out of earlier traditions, and that change happened gradually over time.
So he's not saying nothing changed, just that it wasn't a sudden break.
That's right. He's saying the change was gradual, uneven, and shaped by social and cultural contexts.
Okay, so let me try to put this together. Grant says the scientific revolution was a real turning point, even though it was built on earlier developments. Chapin says the idea of a single revolution is misleading because change was gradual and complex.
That's a good summary, Miles.
And what's interesting is that they actually agree on some important points. Both historians recognize that there was continuity with the medieval past. Neither one argues for a completely sudden break.
So the disagreement is really about how we interpret that change.
Exactly. It's about emphasis. Grant emphasizes transformation and turning points. Chapin emphasizes continuity and complexity.
So where does that leave us? Is there a way to bring these ideas together?
One way to think about it is through the idea of both continuity and change happening at the same time. Historical developments often work that way. Something can build gradually over time and still reach a moment where its impact becomes much more visible.
And that's where some historians bring in the idea of paradigm shifts. Even if ideas develop slowly, there can be moments when a new way of thinking becomes dominant and reshapes how people understand the world.
So maybe the scientific revolution wasn't a clean break, but it still mattered.
Exactly. It may be less useful to think of it as a single event, and more useful to think of it as a process that led to significant changes over time.
That actually makes a lot of sense. It feels more realistic.
And it reflects how historians approach these kinds of questions. They're not just asking what happened. They're asking how we should understand what happened.
All right, let me wrap this up. Today we looked at a big historiographical question. Was the scientific revolution really a revolution? Edward Grant argues that it was a major turning point built on medieval foundations. Stephen Chapin argues that the idea of a single revolution is misleading and that change was gradual and complex. And what we see is that both continuity and change played a role in shaping early modern science. Next episode, we'll turn to the Enlightenment and explore how new ideas about reason, society, and government transformed European thought. Thanks for listening to the Once and Future Present, an AP European History podcast by Hammer History Productions.
Stay curious and think critically. Stay curious and think critically.